Hello everyone, welcome to my video on solutions of integration chapter number 14th exercise 14th A of CHAND. So I have divided the solutions in 4 videos. Do watch all the videos for more clarity. Also like and subscribe my channel if you like my videos. So let's start with the first question. Now in the first question what we need to do is we need to integrate this function. Okay, this is 6x minus 8 upon 3x square minus 8x plus 5 into dx. Okay, now what I'll do here is I'll take 3x square minus 8x plus 5 as a variable. So let's suppose 3x square minus 8x plus 5 is equals to u. Okay, so here what I'm using is I'm using substitution technique. Okay, I'm substituting 3x square minus 8x plus 5 is equals to u. Now from here I'm going to find the value of dx and I'm going to substitute the value of dx, right? Why? Because see, here my whole function is in x. Okay, but now my function will change into u as I'm going to substitute 3x square minus 8x plus 5 is equals to u. So instead of dx I want du here. Okay, so let's do it. I'll differentiate the whole function. Okay, so it would be 6x minus 8. Okay, that is equals to du by dx. Fine, so I can say the value of dx is equals to du upon 6x minus 8. Okay, so let's now substitute all the information in the question. Okay, so it would be integration of okay, I'll keep 6x minus 8 as it is and I'll substitute 3x square minus 8x plus 5 as u. Now dx is equals to du upon 6x minus 8. Okay, so both the terms will get deducted. What finally I'll get is du upon u. Okay, that is equals to log u plus c. Okay, we know the formula of integration of 1 upon u du, that is log u plus c. What I'll do here is again I'll substitute the value of u. Okay, so it would be 3x square minus 8x plus 5 plus c. Okay, so this is the solution for question number 1. Okay, so now let's move on to question number 2. Okay, now in question number 2 we have dx upon 3 minus 5x. Okay, again what I'll do is I'll take 3 minus 5x equals to, let's say, u. Okay, now I need to find the value of dx. Again I'll differentiate the function. So this is a constant quantity, so it is 0 minus 5 is equals to du by dx, or I can say du by dx is equals to minus 5. Okay, so finally what I'll get is dx is equals to, I'll get du upon minus 5. Now I'll put all the values in the question above. Okay, so it would be 1 upon 3 minus 5x as u and dx is du upon minus 5, or I take this constant quantity outside the integration function. So it would be minus 1 upon 5 integration of 1 upon u du, that is equals to minus 1 upon 5 log u plus c. I'll again substitute the value of u, that is equals to 3 minus 5x plus c. Okay, so this is the required answer for question number 2. So let's see next question. Now in the next question I have integration of under root 1 plus x into dx. Okay, so it is quite a big deal to integrate the function this way, right? So what I need to do is I need to substitute 1 plus x, some in a way that it comes out of the square root. What I'll do here is I'll say let 1 plus x is equals to u square, right? So if I'll put 1 plus x is equals to u square, it would come out as u. Okay, now what I need to do is next I need to find the value of dx. Okay, so I'll differentiate, okay, both the sides. So it would be 0 plus 1 is equals to 2u into du by dx. Okay, right, or I can say 1 is equals to 2u into du by dx. Fine, finally what is the value of dx? This is equals to 2u into du. I'll put the values again. So it would be under root 1 plus x, that is equals to u square, and what about dx? That is 2u into du. Okay, So 2 is a constant quantity. I'll take it outside the integration function. So this would become u into u, that is equals to u square into du. Okay. So when I'll integrate this function, what I'll get is 2u cube by 3 plus c. Okay. Why? 2 plus 1 and upon 2 plus 1, that is 3. Okay. I'll again substitute the value of u. What is u? If u square is 1 plus x, it implies that u is equals to under root 1 plus x. Okay. So the answer would be 2. What is u? Under root 1 plus x cube upon 3 plus c. Fine. So this is the answer for question number 3rd. So let's move on to next question. Okay, now in this question, what I'll do is I'll put 1 plus cot x is equals to u. Okay. Now I have taken 1 plus cot x is equals to u. So I need to find the value of dx. What I'll do is I'll differentiate the function. So differentiation of cot x is minus cosec square x, right? And differentiation of u would be du by dx. Or I can say the value of dx is equals to minus du upon cosec square x, right? Putting the values again, I'll get the question as, see, it would be cosec square x upon 1 plus cot x will become u, and dx would become minus du upon cosec square x. I'll deduct this, so it would be minus du. Okay, so the integration for this would be minus log u plus c. Okay, I'll put again the value minus log, and u is 1 plus cot x plus c. So now in this question, I need to integrate cos x minus sin x upon cos x plus sin x. Okay, so what I can do here is I can put cos x plus sin x is equals to u. Okay, now in order to find the value of dx, what I'll do is I'll differentiate both the sides. So differentiating my cos x will give me minus sin x, and sin x will give cos x, right? And u will give du by dx. So I'll get the value of dx as du upon cos x minus sin x. Fine. Now I'll put the values back in the question. So I'll get integration cos x minus sin x. Okay. So this I'm putting as it is, and cos x plus sin x now is u. Okay, and the value of dx is equals to du upon cos x minus sin x, right? So both these terms will get deducted, and what I'll get is 1 upon u into du. So finally I need to integrate only 1 upon u. Now what is the integration of 1 upon u? So that is equals to log u, right? Log u plus c. What is the value of u? That is log, I'll put the value of u, that is cos x plus sin x and plus c. Fine. So this is the required answer for question number 5th. Okay, so in this particular question, I need to integrate this particular function. Fine. What I can do here is I can put log sec x plus 10x is equals to u. Okay. So what I need to do is, now I need to differentiate this function in order to find the value of dx. Okay. So you must be thorough with all the formulas of differentiation. Okay. Now, so what would be what is the differentiation of log x? It is 1 upon x, right? So now here, instead of x, we have sec x plus 10x. Fine. So it would be sec x plus 10x. Okay. Why I have used this formula? Okay. Log x is equals to 1 upon x. Differentiation of. Okay. Fine. Now differentiation of sec x. So differentiation of sec x will give us sec x 10x, and 10x will give us sec square x. Okay. And this would be du by dx. What I'll do is I'll take sec x common here. Okay, so inside the bracket it would be then 10x plus sec x, and I have sec x 10x in the denominator as well. Okay, so what I can do now, I can eliminate both the terms, and I'll find the value of dx as du by sec x. So now the question is very easy. I'll substitute the values again. What is sec x? Okay, I'll put sec x as sec x, and I'll put log sec x plus 10x as u. Okay. And then I have dx. I'll put dx as du upon sec x. So both the terms will get deducted, and finally I'm left with integration of u into du. That is equals to u square upon 2 plus c, right? Now what is u? So u is basically a whole square of log sec x plus 10x. So I'll put it this way, log sec x plus 10x, okay, and 1 by 2 here plus c. Fine. So this is the required answer for question number 6. So let's move on to next question. Okay. Now in the next question, I have integration of cos under root x by under root x into dx. Okay. So what I can do here is I can put under root x is equals to u. Okay, I'll differentiate again. So it would be now 1 upon 2 under root x is equals to du by dx. Okay. So this is the differentiation formula for under root x. Okay. So I'll get the value of dx as du into 2 under root x. Okay, now I'll put the values again. So now it would become cos u, and I'll take this under root x as under root x. Okay, why? Because I have under root x here. So dx, I'll put the value as du into 2 under root x. So both the terms will get eliminated, and I'm left with cos u into du. Now what is the integration of cos u? That is equals to sine u and plus c. I'll put the value of u, that is equals to sine u is equals to what? Under root x and plus c. Fine. So this is answer for question number 7. So now let's move on to next question. Okay, now in this question, what I can do is I can substitute e raised to power x raised to power 2 is equals to u. Okay, now what I'll do is I'll differentiate both the sides. So we know the differentiation of e raised to power x is e raised to power x. Fine. So I'll differentiate this function. So it would be e raised to x power 2 into, it would be 2x is equals to du by dx. Okay, or I can say the value of dx is equals to du upon 2x into e raised to power x raised to power 2. I'll substitute the values again. So what I'll get is, see, I'll put x as x. Okay, now I'll take this e raised to power x again the same. Okay, now I have the value of dx is equals to du by 2x into e raised to power x raised to power 2. So all the terms will get deducted eventually, and I'm left only with 1 upon 2 du. That is equals to 1 upon 2 integration of du. So I'll get the answer as 1 upon 2 u plus c. Okay. Why? Because integration of any constant quantity gives us the variable, that is, if it integration by dx, it will give us x. Okay, so now I'll substitute the value of u, that is equals to e raised to power x raised to power 2 plus c. Fine. So this is the answer for question number 8. Okay, so now let's move on to next question. Now in this question we have integration of e raised to power m tan inverse x and 1 plus x square into dx. See, we know the differentiation of tan inverse x gives us 1 upon 1 plus x square. So what we will do here is we'll put tan inverse x is equals to u. Okay, so now I'll differentiate both the sides. So it would give me 1 upon 1 plus x square is equals to du by dx, right? Or I can say the value of dx is equals to du into 1 plus x square. Okay, now I'll substitute back the values. Okay, so it would be integration of e raised to power m into tan inverse x. I'll put it as u. Okay, and 1 plus x square, I'll keep it as it is. Dx I can put as du into 1 plus x square. Okay, so both the quantities will get eliminated. So finally I'm left with integration of e raised to power mu into du. Whereas one thing note here is m is the constant quantity. Okay, it is the constant quantity, and we know the integration of e raised to power ax is equals to 1 upon a into e raised to power ax plus c. Okay, so similarly integration of e raised to power m by u would be 1 upon n e raised to power mu plus c. Okay, now I'll put the value of u. So it would be 1 upon m e raised to power m tan inverse x plus c. Okay, so this is the required answer. So let's move on to next question now. Okay, so now in this question we have integration of sec square log x upon x into dx. Okay, again we know the differentiation of log x gives us 1 upon x. So what I'll do here is I'll put log x is equals to u. Okay, I'll differentiate both the sides. So log x will give me 1 upon x is equals to du by dx, or I can say dx is equals to x into du, right? I'll substitute the values again in the question. Okay, so it would give me sec square. Okay, log x I can put as u, and x I'll put it as it is. Dx I'll put as x into du. So x and x will get eliminated. Finally, I'm left with sec square u into du. What is integration of sec x dx? Sec square x dx, sorry. So integration of sec square x dx gives me 10x plus c, right? So this is the formula. So we'll substitute, we'll put the same formula here. So it would give us 10u plus c. Fine. What is the value of u here? Log x. So it would be 10 log x plus c. Fine. So this is the answer for question number 10th.